Hello, class. Welcome to Econ 311, Microeconomic Theory 1, and we're going to look at the 9th session, which is the second part of the theory of cost. Some of the things over here are repetitive, so I'm going to rush through some of them a bit because we've looked at some of them in the previous session. Now, in this session, we shall look at the long-run costs and also look at some basic concepts, long-run cost concepts. And subsequently, we're going to discuss the economies of scale and diseconomies of scale. And also, we will look at the minimum efficient scale as well as the economies of scope and the relationship between the long-run cost curves and that of the short run. Now, the session is divided into this, or the outline of the session is given as below. Basic long-run concepts, where we look at what is the long run and the long-run marginal and average cost. We are also going to look at the long-run cost, that is, look at the total, marginal, average cost, and the relationship between these curves. We will also look at the economies and diseconomies of scale, the minimum efficient scale, economies of scope, relationship between long run and short run costs. At the end, I will expect you to be able to understand some basic concept, long run cost concepts, explain the various long run cost curves, understand the concept of economies of scope, understand the relationship between the long run marginal cost and the long run average cost, and also explain the minimum efficiency scale of production, and also you should be able to appreciate the economies of scale and diseconomies of scale. Again, we're going to use the same books, and there is our variant, chapter 22, Jeffrey Perloff, chapter 15, and also chapter 10 of Nicholson, Walter, and Schneider. Now, let's start with some basic concepts. Long run. What does long run mean? Long run refers to the time period when firms enjoy complete adjustability of all inputs. We can't change all inputs, or all inputs in the long run are variable. In other words, there are no fixed costs in this period. And that will mean that we're not going to have fixed costs and also variable costs. All that we have are variable costs because all inputs are variable in this period. Our long-run marginal cost measures the change in long-run costs associated with the change in output. In other words, the long-run cost curve, just as the short-run marginal cost, measures the rate of change in the total cost incurred in the long run with respect to output. Our long-run average cost is also the long-run cost divided by the output that is produced. In general, the long-run average cost curve, just as the short-run average cost curve, is U-shaped. It declines, reaches a minimum point, and rises. When it reaches a minimum point, or as it falls, it experiences economies of scale. When the long-run cost curve is increasing, it experiences diseconomies of scale. Now, our long-run total cost curve is giving us W multiplied by capital L plus our R multiplied by our capital K. And our W is the price of labor, our R is the price of capital, and the labor is the amount of labor and capital that the firm employs or the firm uses. Now, this shows us the relationship between the long-run cost curve, total cost, and the alternative amount of the inputs that we can use. And I believe we saw something similar in the short run, where we said, when we look at the cost minimization and the output minimization topics, The expansion part gives all the information necessary for the derivation of the long-run total cost curve. Since an isoquant gives the amount of output produced and an isocost gives the least cost of producing that output, and the intersection of the two is required for the least cost of producing a given output. Two important properties must transpire here. The long-run cost curve has two important properties. It starts from the origin, and when the output is 0, long-run cost is also 0. Firm is at a planning stage, or the firm is at a planning stage. It also has a positive slope. Least cost of producing a larger output is higher than the least cost of producing the lower output. So there is a positive slope. As we produce more, the cost incurred increases. The typical long-run cost curve, total cost curve, is concave at lower outputs, at lower levels of output, and eventually becomes converse. The next concept that we're going to look at is the long-run average cost curve. And this long-run average cost curve, just as we saw in the short run, is that the formula for calculating is the same. The long-run average cost curve is the long-run cost per unit of output, the cost that we incur on each output in the long run. And mathematically, it is the total cost divided by the total output. And again, it is the same as the short-run cost curve. The formula happens to be the same. The long-run cost curve, average cost curve, has a positive intercept. The minimum of the LAC occurs at the right of the inflection point of the long-run cost curve. For any output level, we can derive our long-run total cost from the LAC. Because when we multiply the output by the LAC, you will get your total long-run total cost. The precise shape of the LAC curve reflects the characteristics of the underlying technology, or simply returns to scale. The addition to the LTC, that is the long-run total cost curve, that results from a unit change in output, is the marginal cost. In other words, the marginal cost measures the rate of change in the total cost. And mathematically, it is given as a change in the long run, long run total cost divided by the output. Graphically, the marginal cost, the long run marginal cost, measures the slope of the long run total cost curve at any given output level. Now we can use table to illustrate this. So we have an output level, we have labor, and we have capital. Then we have the total cost. We have a price of the price of labor to be 5 cedis and the price of capital to be 10 cedis. We can, when we have labor which varies from 10 to 60, capital varies from 7 to 42, we can then determine the total cost, and that will be the price of labor. We are going to use 10 units of labor and 7 units of capital to produce 100 units of output. Now, the price of capital is 10 cedis. So 10 multiplied by 7, that gives us 70 cedis. So the cost incurred on capital for producing 100 units is 70 cedis. And the cost of labor for producing 100 units happens to be the 5 cedis per labor, price of labor multiplied by the amount of labor, which is 10, that is 50. So the 70 plus the 50 gives us a total cost of 120. We can do that for an output of 200 by multiplying the price of labor, which is 5, multiplied by the amount of labor employed, which is 12, plus the amount of capital employed, which is 8, multiplied by the unit price of capital, which is 10, that is 80, and that is 60. And together, the summation of 60, which is the cost incurred or expenditure incurred on labor, plus 80, the expenditure incurred on capital, that gives you 140. So when we do that for the next, you're going to get 200, you're going to get 300, 420, 560, and 720 as a total cost. We can use this to calculate our long-run average cost. We know that the long-run average cost is the total cost divided by output. So having a total cost of 120 divided by 100 gives you 1.2. The next one is going to give you 0.7. Subsequently, at output of 300, we're going to get 0.767. The next one is 0.75, 0.84, 0.93. So we see that our long-run average cost is higher when output is at 100, but falls to 0.7, then falls again to 0.67, then it begins to rise to 0.75, 0.8, up to 1.03. So it falls, which is a minimum, and it rises. We can do the same for marginal cost. And we know the marginal cost is a change in output, is the change in total cost divided by the change in output. So the first one is going to give you 120, then it falls to 0.2 and rises to 0.6 to 1 to 1.2 to 1.4 and 1.6. So again, here we see that marginal cost begins at 1.2, it falls to 0.2, and it begins to rise. So again, it has a U-shaped. So we can plot this, and these are the curves that we are going to get. Okay, so we have for total cost, it is upward sloping, and for marginal marginal cost, long run marginal cost, it is U-shaped. Again, the long run cost curve is U-shaped. But what happens is marginal cost curve intercepts our long run average cost curve at its minimum point. And this is how it looks like. So marginal cost curve is equal to the long run average cost curve at the minimum point of the long run average cost curve. Now, at the declining part of the LAC, when the LAC is declining, it is experiencing what we call economies of scale. And when it is rising, it experiences diseconomies of scale. And so we look at these two concepts. Economies of scale implies that the per unit cost tends to fall as output increases. Okay. So as output increases, the cost per unit of producing the commodity declines. And there are some reasons why we're going to have this. Okay. This include, we have increasing returns to scale. It may also be as a result of specialization in the use of labor and capital. When labor and capital specializes in the production process, that can lead to the economies of scale. Indivisible nature of the many types of capital equipment can also result in economies of scale. Productive capacity of capital equipment rises faster than purchase price, and that leads to economies of scale. Economies of scale in maintaining inventory of replacement parts and also maintenance personnel. That also results in economies of scale. And again, when you purchase in bulk, you get a discount, and that can also result in economies of scale. Also, lower cost of raising capital funds when you are expanding. Spreading promotional and research and development costs can also lead to economies of scale, and also management efficiency. When the firm is small, it is the firm managing activities in the firm is more efficient. Again, there is also this economies of scale that is a rising part of the LAC, and this is the cost per output, the cost per unit of producing the commodity tends to rise as output increases. And there are some reasons for this, and we can talk about decreasing returns to scale, again, specialization in the use of capital, indivisibility of capital, and so forth. Again, disproportionate rise in transportation costs. Again, we can talk about management coordination. When we have huge firm, it's very difficult to coordinate managing of the firm, and that can lead to a rise. That can result in the rise in the cost of producing the commodity. Now, another concept that we need to know is the minimum efficient scale. This is the lowest production level for which the LAC is at its minimum point, or the LAC is minimized. We can have the minimum point of the LAC being dragged out. So, for example, if you have the LAC to be here, and we have between point M and point D, we have a situation whereby LAC is constant. The minimum point, or the minimum output that we can produce at the minimum LAC, which is QMES, is what we are referring to as the minimum efficient scale. So that is the lowest output that we can produce at the minimum LAC. And this may vary given the shape of the LAC. We can have it, so if you look at these two diagrams, we can have it at an early stage when there is this equilibrium, or we can have it or extend it and have it at when there is what economies of scale, and we can have it when we have a constant long run cost. So we have looked at economies of scale. Now the next thing is look at economies of scope. And economies of scope is a reduction of the firm's unit cost by producing two or more goods or service jointly. So when we produce two or more goods jointly, we are able to reduce our costs. And this is what we refer to as economies of scale. And we can purchase economies of scale. And purchase economies of scale arises when large scale purchasing of raw materials enables large firms to obtain lower input prices through quantity discount. So when you get a discount as a result of purchasing your input on a large scale, then we are purchasing economies of scale. For the long run average cost curve, it is an envelope of all the average short run average cost curves, and the minimum will be at tangential, or the short run average cost curve will be tangential to the long run average cost curves. So this is how it looks, and these are the short run average cost curves. Then we impose the long run cost curve. So you see that the short run cost curves are tangential to the long run cost curves. So it is tangential, and you realize it envelopes all the short run average cost curves. Now there is a question, and you have tried looking at this question. The question is, with examples, explain the concept of economies of scale and diseconomies of scale, as well as economies of scope, and also the minimum efficient scale. For this session, the references are Intermediate Microeconomics by Varian, Microeconomics by Perloff, and also Water and Schneider, Microeconomic Theory, Basic Principles and Extensions. Thank you, and I'll see you again in the next session.